Good afternoon, everyone. So we're going to look at our trig ratios of sine, cos, and tan to solve this problem here. So we have an isosceles triangle, which means two equivalent sides, like shown, with an interior angle of 122 degrees up at the top and a base length of 60 meters. And we're being asked to find the vertical and the slant heights of this triangle. Okay, so we'll call these S for slant heights, S, and of course we'll call this H for, well, the vertical height. Okay, so now if our triangle has two equal side lengths, right, then it is isosceles, and that means that down in the center of this top angle is going to split the base into two pieces, okay? So that means that each side of this vertical height gives us an angle of half of the total 122 degrees, meaning that each of the tiny angles at the top corner here is going to be half of 122, meaning 61 degrees, okay? And likewise, because our triangle is isosceles, then having a line going from the apex of the triangle down to the base splits the base into two equal parts, okay? So those two side lengths are also the same. And so now what we really have is a right angle triangle here and the exact same right angle triangle reflected on the other side. And so now we can start using our right angle trig ratios to use sine, cos, or tan. Here we have the fact that since the entire base is 60 and we said that these two side lengths are exactly the same length, we know that they're each half of 60, which of course means that they are 30 meters each. And so now we have a bottom side length of 30. We have a little angle of 61 degrees up at the top corner. So we can use our trig ratios to find the vertical height and also the slant height, okay? So, of course, this is gonna be our hypotenuse, no matter how we slice it. And if we use our reference angle of 61 degrees up here at the top, then across the 30 meters is gonna be our opposite side, and the vertical height would act as the adjacent side. Of course, we know that all triangles have 180 degrees combined, and we have a right angle here, and so we could easily deduce this bottom angle of elevation, angle of inclination. We could do 180 minus 90 minus 61 to get 29 degrees here, but we don't need to do that, right? That would just be a little bit more work than we have to do. So now, let's start with the vertical height. Let's get an equation for the vertical height. The vertical height is the adjacent. We know the opposite, and we have our angle inside of 61 degrees, and so which trig ratio relates opposite to adjacent? That's our tan ratio, and so we can write tan of 61 degrees is equal to opposite over adjacent, right? Toa in SOHCAHTOA. So tan of 61 is 30 over h, and now just a little bit of algebra to get us to our answer. We don't want our unknown in the denominator, so let's multiply both sides by h. And so now we have h times the tan of 61 being equal to 30. And if we want to do one last step of algebra to be proper, let's divide by tan 61 before we actually evaluate it. You can evaluate tan of 61 if you want. It's just a messy irrational decimal. I'd rather not have to deal with that. So let's leave it as tan 61 until we're done our excuse me. So sorry, until we're done our algebraic steps. And now, so now those cancel out, and we get that h is equal to 30 divided by tan of 61. Where's my calculator? That is gonna give us 30 divided by tan of 61 is 16.629, and so I'll say 16.63 meters to be precise, to 2 decimal places, okay? You can check out with your own calculator to make sure I haven't let you astray. And now we also want to get the slant heights, the S on the diagonal, and so that's going to act as the hypotenuse. Now we have both the opposite and the adjacent, but in the spirit of being precise, we know that our adjacent side, our vertical height, we rounded this to 2 decimal places, so it's not exact. The 30 meters on the opposite side is an exact measurement that was given, so let's use that one to improve our precision. So now, well, let's write an equation that relates the opposite side to the hypotenuse, and which trig ratio will that be? From SOHCAHTOA, that's SOH, sine is opposite over hypotenuse, and so we can write that sine of our 61-degree angle is equal to the ratio of 30 over the hypotenuse, which we call S for slant height, right? And now this is a very similar equation. The algebra is going to be identical. So we're going to multiply both sides by S to get our unknown outside the denominator. Multiply both sides, so S times sine of 61 is equal to 30. Again, you can go ahead and evaluate sine of 61, but it is an irrational value. So let's go ahead and divide through the 4 to avoid having to round a messy decimal. And we go ahead and do that, and we find that S is 30 divided by sine of 61, which gives us an answer of 34.30 meters. And that certainly makes sense. S is the hypotenuse. It should be the longest side of the 3. So we have 16.63, we have 30, and we have 34.3. We could verify that this is in fact our correct answers by using the Pythagorean theorem and just verifying that a squared plus b squared is in fact equal to c squared. I'll leave that up to you if you want to check that out. Hope this helps. Thanks for watching. If you guys have any questions, comments, suggestions for future videos, please leave a note below, and have a great day.